The average on a test out of 200 is 110. A random sample of 15 students got the following results. Then we're given a bunch of data, 15 students worth of data. At the alpha equals 0.01, is there sufficient evidence that the average is greater than 110? All right, so we're given some data here. We are not given the population standard deviation. Because we're not given that, we are going to do a t-test. So that's how we know what kind of test we're going to do. So we know it's going to be a t-test. A test equals t. I don't know. T-test. Next, we need to figure out our null hypothesis, which is going to be h naught, and our alternative. And we also need to identify the claim. So let's see what these are. So our null is going to be that something's equal to something because we're talking about averages here. So it says the average on a test out of 200 is 110. So they're saying that the average is 110. And that's a statement just in general. They didn't tie it to any sort of a sample. So they're saying that mu naught is going to be 110, or that the mean is 110. I'm thinking of the calculator. They like to use mu naught. I'll do this in black too. This is 110. So that's going to be our null hypothesis. The alternative is going to be what we're trying to say about it, which at the bottom here, typically where you'll find it is the last sentence. We want to know if we can have sufficient evidence that the average is greater than 110. So we're saying, no, we think that this population average, we think it's actually bigger than 110. Students are doing a little better. So we've got some data here. We can put this thing to the test. Now we need to identify the claim. Well, the claim is what we're trying to say, and here we're saying we're trying to see if we have evidence to conclude that it's greater than 110. So that makes HA, the alternative, the claim. So this one's the claim. Up next, we need to get our numbers out of here. So we're going to get our stats out of the problem. I like to have them separate. So we've already been given the population mean is 110. And that's all we know. Oh, we also know that we had a sample of 15 students. 15 students. So that gives us n is equal to 15. Since we're doing a t-test, we know we're going to need degrees of freedom. Degrees of freedom is just n minus 1. So if you really want to, you could put degrees of freedom is equal to 14. And then we also need, for a t-test, right, we're going to need a standard deviation, the sample standard deviation, and a sample mean. So we're going to need an x bar, and we're going to need an s. So for this, we're going to use a calculator. So we're given data, and from this data, we can find these two numbers. You can do it by hand. More power to you. I'm going to use a calculator for this. So we're going to put these numbers in a list and let the calculator do its thing. So we're going to go to stats. We're going to go to edit, this first one. If you've got numbers in a list, just go up and hit clear and then push down and it will clear the list. So we've got 100, 125, 150. All right, so I've put all my numbers in the calculator. You should see the last number be list item number 15. And then most common source of error, people typing stuff in wrong. So I'm going to go back and double check this. Highly recommend you do this too. It's always worth it. All right, so I've checked it. Everything looks good to go. So we're going to get our stats from this. I will show the chart method and the calculator method for the t-test. So first, let's get our two stats down here. So we're going to go to stat. We're going to go to calculate and one var stats. Number 1, or you can just hit enter. Make sure your list is the list you typed your stuff into. Make sure frequency list is empty and then hit calculate. So we're going to get an average. Oh, look at this. Our average is actually quite a bit higher. We have an X bar of 137.3, and we have a sample standard deviation of 24.12. Remember, we want the sample version because we're dealing with a sample of 15 students. We do not have a population. So we have to go with the top one. All right. So 24.12 and 137.3. And we've got everything we need. Now for the chart method, right, we need our formula. And we know that the formula for a t-test, you could go look this up on your cheat sheet or whatever. A lot of professors allow you to have a list of formulas. It's going to be t is equal to the mean No, it's x bar first. X bar minus the mean over the sample standard deviation divided by the square root of n. It's the same thing as the z formula. It's just, we've got a sample standard deviation. So let's go ahead. Let's just plug these numbers in. So we're going to have x bar, that's 137.3. And this is the test stat, by the way. That's what we're finding, right? Because these numbers are coming from our study. We're putting a test. We're testing this claim. So 137.3 minus the mean, which is 110, population mean, over the sample standard deviation, which is 24.12, divided by the square root of 15, square root of n. And this is how we would do it using the chart in the formula. So we're going to go ahead and I'm going to go back to the beginning and type this into the calculator. Oh my goodness. And so we're going to just type a fraction here, 137.3 minus 110 over, we're going to type another fraction, 24.12 over the square root of 15. All right, so you should type this in. If you can, type it in all at once. I see so many errors with order of operations. If you do it at once, you're not going to have those problems. And we get out a test stat of 4.38. All right, now let's check it with the calculator method. So for those who use the calculator method, we're going to go to stat, and we're going to be doing a test. We're going to be doing a t-test, so that's number 2. Now, the calculator actually can use the data directly. So we can tell it to use the data that we have. We put it in list 1, so we can see list 1. We need to tell it what mu naught is. That's 110. We also wrote it right here, 110. The frequency, leave that at 1. And our alternative hypothesis. So you just match the sign so long as you write mu on the correct side. So we're going to go ahead and do one of these. We're saying that it's greater than the 110. And then we're going to go ahead and go to calculate. Now we can see here, we get the same value, 4.38. So we get verification that we did it correctly. Did I not round the first time? Well, let's go ahead and round right here while we're here. So, right, the 9 would round the 8 up. So we'll have 4.39. And this is pretty much all we need. We could also take this p-value here. Notice the p-value is extremely small, which matches our large t-value. It's e to the negative 4. So that'd be 0.0003. And so I'm not going to be doing the p-value one on this particular example, but we could draw a conclusion right now with the p-value. This is much less than our alpha of 0.01. So we already know that there is sufficient evidence to reject H naught. We can reject H naught because alpha is smaller than this, and there is evidence to support our claim. So if you want to use the p-value test, you can do that. If that just went past you, don't sweat it too much. We're going to do it using the test stat way. All right, so up next, we need to draw the chart. So chart time. And we're just going to draw ourselves a normal looking thing. Whoop. In the middle is 0. And our t values, 4.39, but we need our critical value. We know it's a greater than, and our alpha is 0.01. So the area that lives in here, up in this value area, is 0.01. So if we land in this one itsy bitsy 1% of the curve, then we say that the null is wrong. So if it's anything close to the actual claim, or not the claim, but the null hypothesis, you could be anywhere else in this curve, just not in this 1% of this curve. So we need to find the critical value for this. There's 2 ways. We could use the chart or the calculator. We'll go ahead and do both. We will start with the calculator. So to do it, this is a distribution, right? A t-distribution. And we want a value on this distribution. So we're going to go to the distribution menu. So we're going to hit second distribution. See how it's here in blue. Then we're going to go down to inverse t. Because normally you give it a t-value, it gives you an area. But in this case, you want to give it an area and get a t-value from it. We're going to use that. The area we're interested in is 0.01, and our degrees of freedom is going to be 14, right? Because we had 15 as n. You see here's n, and we put 15 there. Degrees of freedom is 1 less than that. We also made a note of that right here. Degrees of freedom is 14. And then we're going to go ahead, we're going to paste, and we'll do it. We'll hit enter, let it think. And that means our critical value is negative 2.62. And remember now, negative would be on this side, but the distribution is symmetric. I didn't draw it perfect here, but it's symmetric. So it would be like we just flip it over here. So we can just change this to a plus sign because of symmetry. So you might even write a note, by symmetry, positive 2.62, if you do it using this way. All right, so that is how you do it using the calculator. Let's go ahead and find it on the chart. So on the chart, again, we need our degrees of freedom, which is 14. And we're looking for an area with 0.01 in one of the tails. So we're going to come to the t-table. And we've got our degrees of freedom of 14 right here. And we want an area of 0.01 in one of the tails. So we can see one tail, 0.01's right here. And if we come down, we get 2.624, which let me go ahead and just draw a line to that. We go up like that. So this is in one tail. That's the area in one tail, 0.01. And we see we get the exact same number. And we would just take the positive version. Notice there's no plus or minus here because they are using symmetry. So if you're on the negative side, you just take the minus. If you're on the positive, you just take the plus. So now we can come back to our distribution. And so there's both ways of doing it to get the critical value. Now we simply plot our test stat, which is way up here. It's 4.39. And so we say, yeah, people have higher scores than they were getting credit for. The average is higher than 110. No, we can't say that for 100% certain because we only did a sample. So we would say though that we reject the null hypothesis. And then we would say that we have evidence to support the claim. We have evidence to support. We can't say it's totally true because we didn't do like every single person. So at best, we have evidence to support the claim that the test average is greater than 110. And it's pretty compelling evidence. Despite it, we're not able to say for certain, but we can say with a large degree of confidence, hey, we think it's bigger than this. I mean, look at this z-score, or in this case, t-score. Like, that's a far cry away from 2.62. And that's like the most forgiving case before we switch to the, yeah, this is right. So that's how you do a question like this. A couple different ways of doing it. You saw a few ways to check your answer. If you have any questions about this, feel free to drop a comment down below, subscribe, and hit that bell icon for future videos, and we'll catch you in the next problem.